This is BC7950, shrinking RPOs and RTOs of VM replication using WAN optimization. So I talked to a good friend of mine named Mitch Burke, who's a manager of the VC, or of the V specialist team, and I asked Mitch, I said, Mitch, do you think it's okay if I'm funny at the session? And he said, why start now? So we'll try to make this engaging and interactive, and I hope that it'll be fun for you. The clouds are rolling in. Has anybody heard the cloud message this week? 'Cause I think there's something, or one or two things you're talking about cloud something, right? So the cloud's running in. Going to cloud virtualization is great, but it does create other issues. One being WAN replication of your VMs. Anybody here replicating virtual machines today? So I want to call that almost half, right? Is it easy? Kinda. What's the biggest problem replicating virtual machines right now? Anybody want to? Bandwidth. Anybody? Latency, anyone? Latency? If you could have 100 meg pipe with 200 milliseconds of latency, or 2 meg pipe with 0 latency, which one would you take? Absolutely. Latency is what hurts you. Bandwidth it's analogous to if you have to move your car, or if you're moving your home. If you want a big, huge truck, bandwidth, but I've got to drive it to Boston from here to move my stuff. Or latency small would be, I can move my big, huge truck, still big bandwidth, but I'm moving next door, so it's very fast to get back and forth. So think of the bandwidth as how much stuff can you carry, and the latency is how far it's got to take it. So I feel like a general leading you into war today, because about half of you won't be here when I'm finished. It's typically about how it runs, right? So let's talk about what the session agenda is, and I want you guys to speak up. If anybody has any questions, anything that's in your head right now at this moment is more important than what I'm talking about. If you have a question, I want to hear it. I want you to jump up. Anything you're thinking, any question you have is more important than anything I'm saying at the time. What are the priorities in IT? Why is replication difficult? How can we do it more efficiently? What are the benefits of solving the problem? And then, folks, I've got some equipment up here. We're going to talk about what the equipment actually is. And we're going to go through a demonstration and show you what we have, and we're going to replicate and show you some instances and what the benefits are of using WAN optimization tools for replication. Is that what you guys expected to see today? Fantastic. Let's get started. So I think this might be a slide that you've seen once or twice. Last year's cloud priority list was number 14 for CIOs. This year or the year before, now it's number 2. So that tells us one of two things. Either all the CIOs in this country and the world are tricked, right? They're all fooled, or it's real. So I'm going to go with this cloud thing probably is coming. So now that you got your you got yourself a shiny new cloud, your cloud is going to make virtual machine replication more important. When you virtualize, you've got the old analogy and you get the arguments about the folks that say, okay, well, I've got multiple machines running or multiple workloads running in one machine, so it's more important that I protect my information within that host if I have issues, right? So it becomes yet again more important to replicate your virtual machines. Business critical. Who would have thought of putting Exchange into a virtual machine 5 years ago? 4 years ago? 3 years ago? Probably. 2 years ago, 1 year ago. Who has Exchange virtualized now? Is it business critical? Right? Absolutely is. The CTOs, if they were asked what's the most important application in their business today, over 90% of them say email. Right? So if your business application goes down today, you may get a phone call, right? How long does it take your users to call you when Exchange goes down? Right? 10 seconds. So time sensitive. It becomes more important again. We've got growing data. We've got our bandwidth stays the same, so we've got to become more time sensitive about replicating. So who here can tell us, does anybody want to volunteer to tell me what RPOs and RTOs are? Absolutely. Thank you, sir. Would you like a 5-hour energy? You good? All right. Anybody, let me know if you want one. They're up here. That's kind of the team drink, if you will. That and Jägermeister, but we can't do that here. So RPOs is the recovery point objective. So when you say, oh crap, something bad happened, how far back in time do I have to take my data that I can actually find usable data? Recovery time objective is from the oh crap, how long is it going to take me into the future to get back to that point? So I've got two opposing time frames here. How far back in time do I have to go? When was the last backup? When was the last replication? So how far back in time do I have to shift? What did I lose? Anything between here and the oh crap moment is lost data. So I want to shift the recovery point towards 0. The recovery time objective is how long is everything down until it's back. So I want to shove those two together. So the more often I can replicate my virtual machines over to the other side and create a replica set, what do I have? A smaller RPO. Hence, when we can WAN optimize and make our virtual machines replicate faster across the WAN, we have shorter time frames of which do we have to fall back on RPOs. Imagine, if you will, you're climbing a mountain. And I think the guys have the carabiner things that they pop into the mountain so that if they fall, they can't fall any further than the last carabiner. So think of it as every time you replicate, you're putting another carabiner into the mountain. And if I do fall, I can't fall further than that. The reason that you don't punch in every 3 or 4 feet is because it's just tedious to do. The same goes with virtualization. The more often I replicate, the more tedious it is. And as a couple of gentlemen over here said, the more often I replicate, my sand becomes saturated. And what happens when you're sending virtual machine replications, you're typically sending the same thing over and over, even with deduplication. We'll talk about that later. I was talking to the product manager of Redwood this morning, actually. He spoke at noon, if anybody attended that session. He said the good news is with the cloud is the cloud can actually help you to prioritize your workloads in an easier fashion with the gold, silver, and bronze, and to help you to establish exactly which workloads are more important. So if I can start to establish which workload is important, that'll give me the order in which I want to replicate. Believe it or not, has anybody sat through meetings and said, let's decide which applications are the most important, and then they turn out that every single application is the most important, right? So if everything's is priority 1, then nothing's priority 1. So what are the challenges of replicating? Well, you've got growing data. Anybody's data double this year? Triple? Right? It's getting huge. It's ridiculous. We got virtual machines that are getting bigger, and how do I actually replicate them? Am I going to replicate them from within the host? Am I going to replicate them on the array? Where do I replicate? Anybody here need more bandwidth? Right? Everybody should probably raise their hand. So the challenges are there. So we've got huge VMs. Anybody CIO telling them don't worry about SLAs, we'll just give me the best you got? No, right? They're saying I want zero downtime, I want more effectiveness. So you got slow WAN. Anybody being asked to do more with less this year? Everybody. Shrinking IT staff. So you got demanding SLAs that are crushing you. You got critical apps that are happening, they're getting bigger, and the WAN's over congested already, and anybody's users calling and saying, hey, the applications are slow. All this forms together. You got to have shrinking SLAs, VMs are getting bigger, I need you to be up all times, I want you to be safe, and all these opposing forces are crushing against the pipe. So, when deduplicating across the WAN, this is going to get a little bit technical, and I can go as deep as anybody would like to. I've personally have installed about 3,500 WAN optimization devices in the world. So I can talk about as technical as you want to go, and I enjoy it. So what happens is we're going to show replication from the data center over to a DR center. So today, we're running Uber VSA. If anybody knows Nick Weaver from Nikipedia, he created the Uber VSA, and we're running that today thanks to Nick. Thank you, Nick. So we're going to have the Uber VSA is going to actually request over to replicate. So it makes a replication request and says, hey, here comes some data, or I need some data. And the device says, okay, here you go. What happens is the data leaves the data center and it approaches the WAN, and when it gets to the WAN optimization device, the WAN optimization device looks at that data and it says, have I ever seen this before? And it says, I've never seen this data before. So I'm going to write it to my hard drive. I'm going to put metadata on it or hashtag so I can recall it later if I ever see it again. I'm going to compress it to my best ability, and I'm going to shoot it across the WAN using a couple of other TCP/IP tricks like pooling and other things. And TCP/IP pooling in WAN optimization terms means this. If we were to all leave right now and go to SFO to all go to Atlanta, Georgia, which is where I'm from, if Delta Airlines were to give us a plane as soon as we got there, that's typically how TCP/IP works. As soon as you get to the endpoint, the machine says go. So imagine every single time you go to the airport, Delta gives everyone a 747 regardless if it's full or not. That's what's happening. So a packet in flight across the WAN has the exact same overhead. An empty packet has the exact same overhead as a full packet. It's kind of like a car on the highway. If you got 6 people in the car, it's more efficient than having just one car like we do in Atlanta. We're only allowed to have one person in the car in Atlanta, just so you know. So imagine, the car with one human being in it takes just as much room in traffic as the car with 6 people. So what these WAN optimization devices do is they actually halt the traffic in mere milliseconds and say, hang on 1 second, much like Delta does when you get to the airport. Let's fill the plane up before it takes off. So if we keep less planes in the air or less traffic off the WAN, we reduce latency. The more we reduce latency, the better off performance we get. So it intercepts a response, segments the data, chops it up, and puts it into metadata tags and says, I can remember this data for later. Compresses it, sends it across the wire, and gives it to the requesting sender. Now when it gets to the other side, it rehydrates the data, and it writes the hard drive in the exact same mathematical format as it did on the other side, and then delivers the data. So if the client requester asks for the same information or even pieces or parts of the same information, the WAN optimization device says, hold on a second, you're a 150 meg ISO file or even a gig ISO file. You've already come to me before and gone across the WAN. Instead of sending the entire gig ISO file again, I'm going to look up your metadata, and I'm going to send 1 or 2 packets across that says, hey, you've already got that 2 gig ISO file, and it's called XYZ98453. Look it up on your local hard drive and deliver it to the requester. So I get a 2 gig request. The 2 gig comes across the LAN, gets to the edge WAN optimization device. The WAN optimization device says, stop. I got it. Sends 1 or 2 packets across the WAN that says, hey, look up that information you already have, and delivers it to the requester. So you go request, full speed, 2 packets, full speed. So to the requesting client, it looks like it's going almost sometimes 50 to 80 times faster than it really is. Is there any questions there? Heads nod. Yes?
So the WAN optimization, I mean, obviously they have protocols for SIFs and NFS and stuff like that. How does it work with replication? Because you have different replication technologies. Do all these appliances know about it, or do you actually go into the appliances and configure them?
So my team uses Cisco or Riverbed to do these. So today we have representation of both of the guys. And so it depends on which tool you use. Some of them are layer 7 aware and some of them are not. For Cisco and for Riverbed, they're both layer 7 aware. The question is if you're using some replication protocol, how effectively like a thermos, how does the thermos know to keep it hot or cold, right? How does it know? So the WAN tool either at layer 4 says, oh, that's a packet, I can either do something with it and passes it on or not. Or sometimes it says, I know what this tech protocol is. I know this is layer 7, this is replication, so it can intervene. Does that answer your question? Okay. Yes? Can you speak into the mic so we can capture your question?
Does the sending side need to see the whole file before it can know what to do with it, or is it a streaming algorithm?
So are you asking me, does this side...
Right. So you're the Riverbed on the left, how much of the file does it need to see before it knows whether or not...
Okay, this is a great question. This transaction that goes back and forth happens in the exact same manner as if if there are WAN optimization devices in the middle or not. So the same request, it's not mimicked, it's not hashed, it's not proxied or any of that. So if this guy makes a request, he responds in the exact same manner, rather if there's a riverbed in the middle or not. So the only difference is if you sniff the network here on the LAN and you sniff the network here on the LAN, they're mathematically identical. You can't tell that there's any type of WAN optimization device at all. If you sniff here in the middle, sometimes you can, sometimes you can't. That's for a whole other discussion. But there's no difference in how the request gets made because there's a WAN optimization device in the middle or not. I'm not sure I answered your question. No?
Close enough.
Okay. Yes?
Is it block level or file level?
So this would be byte level. So caching is kind of the first rendition of the first version in the industry. Caching says, I make a request, you have that file, so instead of going to get it, I actually just respond to you locally, and then I can update in the past, and later I can go back and update the server that transaction happened. And that's kind of the old method. Nobody really uses that anymore. That was kind of the, my brain just went blank. The older versions of WAN optimization devices actually did that. Today, what's happening with WAN optimization, and Cisco and both Riverbed do this, is when a request gets made, the entire request goes all the way across. Another thing that was bad about caching is that when this request was made from here, this box would actually respond back as a requester to the server. So you couldn't tell who was actually asking for the file. So today, in today's generation WAN optimization tools, we're going all the way across to the other side for every single request. And we're logging into the server as the user, not as the caching device.
So going back to your ISO example, where it's grabbing it from the left,
Yes.
bringing it to the right, if that ISO has been transferred in the past, it's traversed through both devices, it's sitting on the disk somewhere right now. So if I request it for the second time, the WAN optimization finds on the left-hand side goes, hey, I've already sent this across 2 days ago. Where is he going to find it on the right-hand side?
When or where?
Where? How is it going to deliver it again to the data center?
So request gets made. It comes across fully hydrated here. The WAN optimization device effectively stops it at the border and says, I got this. You don't need to go. You don't need to make the trip across the WAN again. It sends a mathematical representation across the WAN in a very small packets that say, hey, look this information up that you already have, recreate that entire TCP session, and re-blast it out the LAN side to the requester.
When it's recreating, I mean, the ISO, the entire 160 meg ISO,
Right.
big ISO, where is it recreating it from?
Where?
It's got some kind of caching, has it seen it in the past?
Right. So there's a data store here that has all that information stored. And so there's hard drives in each of these devices. That's probably what I should have said already. Sir?
I wanted to take another shot at this question, and I was wondering the same thing, really. When the unit on the left, at what point does the unit on the left start sending those hashes to the unit on the right to tell it to start linking? Are they in 4K blocks, 16K blocks, or does it wait
16K blocks. Does that help?
Yeah.
And the interesting thing is, in what mathematically my head can't get there yet, and I don't know that I ever will, is that these devices, Cisco and Riverbed, both do such a great job of sending reference data across the WAN that the actual references start to become redundant. So references start to reference references, and those reference other references. So you can have data that's one packet that can represent references 4 layers deep. So one packet can actually represent hundreds of megs of data across the WAN. It's amazing technology. So here we're showing that 10 gig of a replication request was sent. I want to send this virtual machine across the WAN. And it actually sent, it said, hey, I need to send 10.5 gig across the WAN. But the WAN device intercepted it and only had to send 687 meg across the WAN. So it's 15 times faster. So one of two things can happen. Either I can send 15 times more data in the same amount of time that it would have taken, or I can do it in a much shorter time frame, one or the other, or a mix of the two. right? Everybody agree with that? So I can either say I would have sent 10 gig, but I only had to send 700 meg approximately. So it's going to either happen in 1/15 of the time, or I can now send 15 times 10 gig in the same pipe. Yes, sir. So this representation here was a virtual machine. And yes, it was a virtual machine that had been seen before. So that's what we call warm data. So and your mileage will vary. If you try to use, say, medical imaging for radiology scans, bad. Right? So you got gigs and gigs of these huge files, and they're never duplicated. You got it. Absolutely agreed. Question. You good? So another use is also we can actually start to P2V and to start migrating applications across the WAN in pretty much real time. So the interesting thing happens is that if I send the virtual machine, say the C drive of the operating system, across through these WAN optimization tools, and then I send in a completely different install, but maybe the same operating system, guess what happens? It's seen that information. Now it's a completely different virtual machine, but it's effectively the same DLLs. So what happens is you start to, as these devices learn, they get faster and faster and faster. And one common question is, well, how long does it keep the information? The answer to that is, it keeps the information as long as the hard drive allows it to keep. So if I've got new information coming in, and let's say the entire data store, the hard drive is full, having the data store full is not necessarily a bad thing, because there's a higher statistical chance that I'll hit a reference that already exists. So if my hard drive is full and I do have new data coming in that's unique, it will throw out the oldest, least used information. Now the reason you throw out the oldest, least used information is that on day one when you install these appliances, one of the very first things that comes through would be your company logo and an email. So that's one of the very first things that comes through. And it might be one of the oldest pieces of information in the data store. Now literally a year later, when the hard drive fills up, it'll look through and say, that's old information, but I use it all the time. So we're going to keep it. Questions on that? Yes?
Do you actually see people doing P2P?
Absolutely.
Across the WAN?
Absolutely. Effectively, too.
Right. What size links do they have?
The question is, what size links do they have and what's the latency? Now, the interesting thing to understand, and I'm going to show you, we're going to show 120 milliseconds of delay on the wire. Albert Einstein figured out that the speed of light is a very standard form of speed, and that can't be changed. So these WAN optimization devices don't take that 120 meg or 120 millisecond of delay and reduce it to something less. It has to stay that because you can't beat the speed of light. But what it does do is it masks the symptoms that the 120 seconds of delay or 120 milliseconds of delay would produce. So it's interesting. People say, well, how fast will it go on such WAN link? So if I have a T1 link and I do the math, and the math is the math, no matter what information you throw through it. So if I put an ISO file through it, and the math becomes, it's 16 times faster, and I'm on a T1 link, then I'm going to be 1.54 times 16 faster. If I take that exact same ISO, run it through WAN optimization over a 45 meg circuit, it's going to be 16 times faster times 45 meg. So the multiplier is the same regardless of what the pipe is. So the more pipe you can throw to it, the higher the multiple. Because the mathematics work the same regardless of the bandwidth. Everybody understand? Everybody good with that? Did I answer your question? So here we see another replication, CN replication, where they requested 8.5 gig, and it took about a gig to get across. So what that says is that 87% of the data requested to go across the WAN did not have to make the trip. So the fastest trip around the WAN is the trip not taken. My wife will say, hey, Fred, I need you to go to the, well, she didn't call me Fred, but Freddie, I need you to go to the store and get some milk. And I say, okay. I walk out into the garage refrigerator and grab the milk. I've already got it. I don't have to go to the store. Right? So it's the fastest trip I can make because I already have it available. So what are the benefits of using WAN optimization for replication? We talked about earlier the RPOs and RTOs. So remember, RPO is oh crap, how far back in time was our last backup, or replication, and how far ahead is the RTO. So if I can make these links 15 times faster and I can replicate 15 times more often, what happens to my RPO? It's 15 times closer, effectively. And RTO would be, if I've got to come back, I can get that data back 15 times faster. So I can move in and get closer and closer to ground zero, if you will, for when the disaster happened. Move more VMs or less time. And that's effectively when we said if we're going to run it 15 times faster, we can either put 15 times more data in the same pipe, or the transverse, we can do it 15 times quicker, one or the other. Or a mixture of the two. Typically companies, what happens is, I've seen it time and time again, your pipe was so saturated you can't replicate. All of a sudden you reduce the workload on the pipe, and so what's the SAN administrator do? Woohoo! I can replicate more data. And they just fill it right back up. But now you're doing it 15 times. You're replicating 15 times more data. So network congestion. If I can remove if we go back and look, if I can remove 87% of the traffic across the pipe, what happens? Anybody want to remove 87% of the traffic in your hometown on the highway? Right? What would happen? Where I live in Atlanta, we either do 90 miles an hour or 15 miles an hour. There's no in between. I see you laughing back there, KZ. He does more than that, I think. So if I can relieve network congestion, then I relieve traffic off the wire, then what happens is, if my SAN is crushing the line, anybody back up across the WAN or do replication across the WAN? Do you do it in the middle of the day? Do your users complain? Kind of, sometimes maybe, occasionally. Right, so what if I could relieve the network congestion, then I could start replicating and have my users happy at the same time. Right? Cake and eat it too kind of philosophy. And possibly postpone network upgrades. What time do we have? Almost 2. Okay, great. So push your RPOs and RTOs in. Either send more VMs or send the same ones in less time. Reduce the traffic off the WAN and postpone network upgrades. Now for the most dangerous words in IT. Watch this. What we've got up here today is I've got a server running ESX, and then again it's running the Uber VSA version, so it's running a virtual SAN inside the machine locally. I've got a WAN optimization device, be it Riverbed or Cisco. I've got a WAN simulator device, which is called a networking nightmare. This device, so imagine, if you will, this was the data center to the edge, to the router, right? So this would be in one side, and this is the WAN, and this guy is dialed down to a 0.5 meg per second, 512K, and 120 milliseconds of delay. So it comes out the other side, now we're into the data center, or the disaster recovery center, and then the ESX server on the other side. Make sense? Yes? No. I have one Cisco device here, so it's here so that we can take a look at it as well. But just for today's demonstration, we are using Riverbed. All right. Excuse me. I'm going to log into the vSphere client and just show you a little bit of what the environment looks like. So we've got the Unisphere server on one side. And for today's demonstration, this box here would represent the disaster recovery side. So it's the receiving end of the replication. On this side, we've got the sending side of the replication. We've got the management machine, which I'm going to use for the demonstration, and then I've got the performance machine. In the performance machine, it's constantly changing. So the data is constantly shifting so that it'll kick off the replication schedules for Unisphere constantly every 5 minutes. What I'd like to show here is I'm pinging across the WAN, if you will, and you can see that the WAN actually does have 120 milliseconds of delay on the wire. And what we've done is we used a program called Minifiles and some other things to actually create movement of data and to continuously make changes to the device so that it'll kick off replication. What I'd like to show here is this is an example. I talked to you about 50 to 80 times faster. So this is a half meg device running at peak LAN throughput of 122 megabits per second. So what's happening here is we're paying for a half meg pipe, and it's performing at its peak like a 120 meg circuit. Anybody know what a 120 meg circuit would cost you in your location? Could you pay for it? Maybe, maybe not. What if you could take one time and you could take that half meg circuit and act like a 120 meg pipe? That's the power of it. So when I can make that 120 meg pipe work that fast, what happens is I can start to send more replication through of VMs through my over VSA. When I do that, I create my RPOs and RTOs become closer. So this is the Unisphere administration tool, and we're going to take a look at, this is a replication object set up between the two SANs. And what we're going to show here is the last replication. So we're saying that our source is okay, our destination status is okay, so it's replicating every 5 minutes. So the previous transfer rate, take a look at that. The pipe is how big? A half meg. The application is the Unisphere server. That's the application. It's reporting, where did I put mine? The application has the bottleneck of a half meg pipe. That is mathematically done. There's no changing that. Yet, my replication report is showing me that I'm running almost 6 meg a second. Why is that? Because it's sending data over towards the WAN optimization tool at that rate. Everybody follow that? So if I'm coming out at 6 meg a second to that machine, if we turned off WAN optimization, you'd see that go down to a half meg. So won't make anybody do math here, but if you'd let me graciously round that up to 6 meg to make the math easy, we're running approximately 12 times faster. So not to beat a dead horse, but if I'm running 12 times faster, I'm replicating 12 times faster, or I'm sending 12 times the data. RPOs, RTOs come together. Agreed. You can do the math, it comes out to about the same. Agreed. So this would either be 512 KB per second, so you can do it that way as well. So 58 divided by 512, same math. What's that? So this is 80 times better. So my math was off. So it's important to see, it's important to see my average read rate and the average write rate, or the average transfer rates too. So at its peak, the previous transfer rate was 6. The average is still much, much higher. Just for an average, sir.
Is that volume deduplicated?
Absolutely. Which volume?
The volume you're transferring.
So I want to tell you when I know something, when I don't. Nick, make.
So it's not,
Replication was not turned on in this.
So it's also important that you deduplicate pretty much in one place, or otherwise you can cause trouble there mathematically, and that's for any of the WAN tools. And that goes for compression. So I want one. Pardon?
vacuum artificially inflate that number. If you're not deduplication, there's more
Well, it can, but also these WAN optimization tools actually do deduplication better than some of the other applications do, because that's what they're purpose-driven for. So you want to turn off, in most all of your applications, you want to turn off compression and turn off deduplication and let the WAN optimization tools do it, because they do it better. Plus, you're offloading that process that has to happen. So if I want to deduplicate there, then that's host processes that don't have to happen. All right, let's continue. So what I'm looking at here is in the last hour, and this gets back to your point, sir, in the yellow shirt. In the last hour for our replication, it's requested 296 meg of data to be replicated, and it's only had to send 2 meg across the wire. That's sick. So again, not to beat a dead horse, 99% of that data, 99% of that 200 plus meg of data did not have to go across the WAN, right? Almost 300 meg. So if I've got Exchange users and people using CIFs and copying files back and forth and trying to use the WAN, 294 meg of data didn't have to compete with my users for their data. And I also was able to send that information, again, driving my RPOs and RTOs closer together to keep my virtualization or my virtual machines safe. The more times I can replicate in my virtual machines, the safer I am. Questions? Yes?
I guess the simple question would be is, if you have much higher change rates, though, would your optimization go down? Because
Yes. So the question is what if my change rate's higher, what happens to the optimization levels? So the mathematics are the mathematics, and there's some smart people at Cisco and also other companies that are working on tweaking those mathematics to make them better. But when you take an application or you take data and you shove them into those mathematics, it's going to come out the exact same way every time. And what I mean by that is you can take, if you took a flat file of text, say a 2 gig text file, and shoved it through Cisco's WAN optimization device, it's going to smoke and haul butt. But then if I take, like we talked about earlier, if I take a respiratory image from medical imaging and put it through the same device, it's not going to be able to work as well on that information. So it's very much dependent on what applications you're trying to optimize and what types of virtual machines you're pushing through. Databases seem to just haul butt because normally databases are not normalized as well as we'd always like to have them, and they're very much repetitious in what they're sending. So Oracle and SQL, using their tools to replicate the application, to replicate the virtual machine, sends the same thing over and over. They'll tell you that they're only sending change data, but the conversation still has to happen. So I'd like to send you some data. Are you ready? Yes, I'm ready. Did you get that? Yes, I got that. Send it again. Yes, back and forth. This replication request actually become redundant. So we can remove that as well. Question? Over here, I thought we had one. So what we talked about today was the importance of pushing your RPOs and RTOs together and how we can effectively reduce and make your virtual machines safer by being able to replicate them either faster across the WAN or either be able to put more information through that same WAN. Yes? Can you talk into the mic for me?
Yeah. I guess this still feels kind of like a hack to me. And I'm just curious in general. I mean, every time we need a new feature sort of like this, or we're going to have a new Layer 7 device, we've got to sort of chain all these things together. And I mean, is it unreasonable that we should expect, TCP pooling from the OS or better deduplication from the arrays? I mean, do we really need this? Are we still going to have these in 5 years?
That question comes up. The idea that Cisco wants to do is they want to start to move this WAN optimization, and we have our friend from Cisco here today. So the question comes up, I believe that Cisco is starting to drop those mathematics back deeper into the network. Yes.
I'm the product line manager for WAS, the Cisco product that we're talking about here. So some of these technologies, especially the dedupe technologies, for instance, they're pretty intensive on resources. right? So you need a reasonable amount of resources. So whether it's a blade or a separate piece of hardware, you need to dedicate some resources. The other one is that there's also an implication on the location and network, right? So if you see where these devices go, they actually have the advantage of seeing aggregated traffic from a large number of sessions, right? So that gives you a greater power in terms of the dedupe itself. Now, at Cisco, one of the things we are doing, I think to what you were alluding, is taking some of these technologies and to the extent that we can take as many of these and put them back into the networking fabric or the storage fabric, we are doing that. So on MDS switches, for instance, there is increased levels of compression and available. Again, in an aggregated manner, you can take it in. The TCP optimizations, different parts of the network, they're starting to show up in various switches and routers.
So applications may change, but the protocols that the IEEE ratifies for TCP don't change very often, right? So that's pretty flat. TCP is about, I think it's 41 years old now, and it hasn't made that. I mean, it's changed a few times, but it's pretty steady as far as having to rework it. Yes.
Fred, are there any scenarios that either scream out for this technology as a best fit, or alternatively ones that are potentially real landmines where you want to avoid using this?
Mm-hmm. So the question is where does this technology fit great and where is it not so great? If it's great when you're replicating virtual machines that have the same operating system footprints and the same data patterns. So if I can show like databases with SQL that have the same information. So if I'm sending a SQL virtual machine or let's say an Exchange virtual machine that has emails, and you send out emails with PowerPoints and it goes to a distribution list of 150 people. So when I send that across, it's going to do really well. Where it doesn't do well is imaging type databases, and my friend from Cisco can answer that a little bit better than I can. But when you've got data that's image-based data, movie type data, media formats are tough, those types of things, MP3s. But when you have end-user unstructured data, CIFs, access databases, emails, Oracle databases, Exchange databases tend to work amazingly well. Yes, Tony? Great question. So Cisco offers multiple devices, so you can go from, you've got regional office size, you've got small office types. There's also software that you can put on your laptops that'll do the same thing. You typically wouldn't use the software to replicate virtual machines, which is what the session's about. But we can size them from 3, 5 person offices all the way up to 10,000 users or more. And I'm sure we have many, many references for that. Sir?
I just wanted to do the earlier question, when does this work best and when not?
Can you step up to the mic, please?
Yeah, sure. So the WAN optimization device, or WAS, has multiple levels of optimization. So there is TCP optimization, there is dedupe, there is compression, and then there is application optimization, right? So depending on the kind of data, depending on the kind of application, you can get all or any of these optimizations. It's not just dedupe.
Sure. And the session really didn't have time to go into it, but he makes a good point that there's multiple layers of optimization, TCP optimization, deduplication, application at layer 7, and all of these things form together to show the benefits that we talked about today. Yes, sir.
In your opinion, I know there's people from Riverbed in the room and also Cisco. Which one do you prefer for your?
I like them both. They're great.
What would be the pros for Cisco? What would be the pros for Riverbed?
Yeah, let's take that offline probably. Yeah, I mean, do you want to hear it from me or do you want to hear it from a customer? I think that'd probably be better. Sure. Sir?
So you said it's best to dedupe only in one location. So currently I'm deduping my backup data and then replicating that across the web.
Great.
That's kind of an add-on. I'm looking at a storage refresh, so we're looking at deduping the storage. But I'm still really interested a lot in
Great.
maximizing my data across the WAN.
Okay.
Because that's where it's got to end up in VR. So what guidelines are there for determining where is the best place to choose the deduplication?
So the interesting thing is you always get people that say, I want references, 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 references. And then they say, okay, now I talk those references, we've got to try it in our data center because we're different. And so you get one and the other. So my answer to your question is that Deduplicating data at rest is good because you save storage space, right? What you have to understand is if you duplicate it at rest and then you send it through the WAN optimization tool, you're going to get less optimization off the wire because it's already been deduplicated once. Now, Cisco does a really good job of taking that data and optimizing it yet again because, as we talked about earlier, there's 3 or 4 different types of WAN optimization, deduplication just being one of them. So if I'm deduplicated, we can still push it through a WAN optimization device. It probably will deduplicate it further because the tool is better at deduplicating than most of the applications. But remember, we've got 3 other types of WAN optimization that can still help you. So deduplication can reduce, if it's already deduplicated coming in, it can reduce the output of the optimization of that layer, but you still get some help. Sir.
Yeah, full disclosure, I'm with Silver Peak. We're also in the WAN optimization business, and I love your presentation, Fred.
Thank you.
Absolutely great. Music to my ears. It's just I wish you had also had Silver Peak when you talk about Cisco and
Sure.
Riverbed, since EMC internally and VMware
Absolutely.
internally use Silver Peak, and EMC's been selling
Absolutely.
Silver Peak for replication for the past 2 years. The question, by the way, though, is one of the trends we see as a lot of large enterprises start to move replication from dedicated private line bandwidth onto their shared corporate network with MPLS infrastructure, or even running over the public internet. Oftentimes, it's not just bandwidth and latency, but packet loss and congestion become the gating item for
Sure.
replication throughput. Could you comment a little bit about that in terms of how that plays into WAN optimization?
Sure. I completely understand your question. It's a great one. So Silver Peak does do a very nice job of doing the packet loss, and I think that's something that you guys are leaders in, I guess, is why your question's formulated that way. Certainly is important. If you send a reference across and you get packet lost, then the reference certainly has to be resent. I understand that you guys are not as what's the right word, focused on layer 7 as the other competitors, and you have arguments that say doing it at a different layer lower is actually a more effective way to do that, and that's really a religious question. Agreed. And my apologies. It's just, go ahead. Yes, sir.
How about SSL traffic? How does
So,
do that as well?
vendor to vendor, yes, some vendors can as well. So you do have to have the certificates, and the certificates have to be placed on the box. And the different vendors have different variations and ways to do that. I think that's, would you guys, so we have multiple vendors here. You guys would agree that SSL optimization is pretty standard today. Okay. Further questions?
How would it work with more than 2 locations if you had multiple sites that you wanted to sync up?
Okay. So across all vendors, you'd have a home machine that's large enough to scale out to handle kind of an octopus type format. So you'd have a larger optimization tool in your data center, and then you'd have appropriately sized devices out into the remote offices, be it a regional office or a small remote office. And the inbound requests coming in, the data center unit would be large enough to handle those requests.
Is that a concept of global communication?
Yes.
Similar to
Yes, and so we're getting now into whiteboard type stuff where you can probably spend 3 hours. There's different variations on how that works as well for single instance storing in the data center boxes, and all the vendors have different ways of doing that as well. And they're pretty aggressive about saying, one's right versus one wrong, and that becomes very religious. And the Silver Peak guy's laughing. I agree. Yes?
Can you speak to optimizing recover point and VPlex in addition to square root?
So VPlex is being tested with a bunch of the tools today. Recover point works in the 6 to 7 times faster range, depending on what you send to it. So it's not in the 50x range like CIFS would be, but if you can say recover point works 6 times better, I'll take that. Again, the math is the math, right? So no matter what you send to it, it's going to do the exact same formula mathematically across all vendors to that data. Whatever comes out the other side is your optimization level. These have been very great. These have been great questions, sir.
How would you size the data store whenever you're dealing with recover points or?
So again, I've got spreadsheets that I can help you with and say, okay, if you start with this size data, You got this much latency, this much bandwidth, you got this understanding of what you believe your change rate is. I want to replicate 4 times a day, put all that into a spreadsheet, and then let's start out low and say, okay, if we can do that 3x better, can we get there, red or green? So you got this much data, this much change rate. I want to do it this often. Can it happen? And the mathematics come through, and it's basically spreadsheet and says, if I can go 3 times faster, no, it's not going to happen. I'm going to have to get to 6 times faster. So then you can start to do shifts in formulas and say, okay, if I agree that 3 or 6x is the number, then what's my multiplier on the bandwidth got to be able to replicate that amount of data?
But the individual data store size doesn't matter as much as the consolidated aggregate, correct?
That's correct. So what he's saying is the actual data store is the amount of data stored doesn't actually change the mathematics as it happens. The intention of having more and more and more and more data store is that the more references that I have, the more likely I am to hit a corresponding reference and be able to optimize that data. So having more and more data doesn't change the mathematics, it just has a greater statistical chance of hitting that reference. Right? Right. Does everybody follow that? So the amount of data that you have doesn't change the actual mathematics. It just changes the more books I have in my library, the greater chance I've got a copy that you want. And again, the guys are smiling in the back. That becomes another, handling the bigger data stores becomes yet again another religious war. Other questions? Hey, I'm happy to answer more. Stand up here till I'm blue in the face. Thank you very much for coming. I hope it was worth your time.